Hello all, my name is Ashutosh Rastogi. I am a teacher by profession. My mission is to impart quality education for all. For that purpose, I am creating these videos. If you appreciate my work, then please do like my video and subscribe my channel so that I could get the motivation to prepare more videos. Anyways, today in this particular lecture, we are going to discuss about your introduction to receivers, in which we are going to specifically discuss about the desirable conditions of your receiver such as your selectivity, sensitivity and fidelity. So these are the outlines. We're going to start up with the introduction. Then we're going to describe what is receiver, what is the basic role of receiver. Then we're going to discuss about the functions of radio receiver, that is what are various functions associated with your radio receiver that any radio receiver must have to perform. Then we're going to discuss about the desirable characteristics of your receiver such as your selectivity, sensitivity and fidelity. What are they and how can we achieve them? And finally, we're going to conclude by discussing the classification of radio receivers. So in our general communication system, we will be having three basic blocks, that is the transmitter, receiver, and to connect between transmitter and receiver, we'll be having some channel. So the transmitter modifies the message signal in such a way that it can matches the channel characteristics so that signal might get easily transported through the medium or channel to your receiver. At the receiving side, it is your receiver's responsibility to get the actual message signal. Obviously, in order to match up the channel characteristics, transmitter will going to modify our information, such as it will going to amplify it, it will going to modulate our signal, and there are several different other things that transmitter has to do. So obviously at the receiving side, it is your receiver's responsibility to get the actual message signal back. So receiver basically performs the reverse operation of the transmitter. In simpler words, we could say that receiver has to perform the reverse operation of the transmitter. So what is a receiver? A receiver is a hardware module or device which is used to receive the signal of different kinds depending upon the context of applications. Obviously, if you are talking about your AM, FM, your television, your radar or any other application. So it may receive analog electromagnetic signal. Obviously, if you are talking about your wireless communication, or waves or digital signals through your wired media. So specifically, a radio receiver is an electronic equipment which picks up the desired signal. Obviously, if you are talking about your wireless communication system, so in our wireless environment, we'll be having several signals which are ranging over multiple frequency ranges. So radio receiver is an electronic equipment which will going to pick up the desired frequency signal depending upon its application where we are using that particular receiver. It rejects the unwanted signal. Since we have already discussed that the environment is full of multiple frequency signals, so we have to reject the unwanted signals also. Then demodulate the carrier signal to get back the original message signal or modulated signal back. So this is the sole functionality of your receiver, and this is all about your receiver. So now functions of radio receiver, that is what a typical radio receiver must have to perform. So first of all, it must have to intercept the incoming modulated signal. So obviously, since wireless medium is full of multiple frequency component, so obviously our receiver must have to intercept the incoming modulated signal, or you could say your desirable signal. Select the desired signal and reject the unwanted signal. Since in our typical wireless environment, we will be having multiple frequency RF signals, so a receiver should in a state to select a particular desired frequency band signal and reject the other signals. Obviously, receiver have to select the desired frequency signal and must have to amplify it so that we can get the better signal at the reception. Then detect modulated signal to get back the original modulated signal. So after amplifying that desired RF signal, we must have to pass it down through your demodulated circuit, which will going to get the actual message signal back. And then further we have to amplify the modulated frequency signal or desired message signal so that we can have the better quality. So now the desirable characteristics of receiver. So what are the various desirable characteristics of a typical receiver? They are: a receiver must have to be highly selective, it should be highly sensitive, and it should possess high fidelity. So what are these three typical terms? We will be going to discuss one by one. So first we are going to start up with your selectivity. So what is selectivity? Selectivity of a device, here obviously we are talking about your typical receiver, to respond to a particular frequency without interfering from other frequencies. Since we had already mentioned that our wireless environment is full of multiple frequency component, such as we could say that in your wireless environment you will be having your AM signal, your FM signal, your TV broadcast signals, your mobile communication signals, your satellite signals. So there is a variety of RF signals that are available in your environment. Selectivity is the ability of your receiver or device to respond to a particular frequency range only. So it refers to the ability of a receiver to select a signal of desired frequency while reject all others. So obviously if we are talking about your typical FM system, then your FM receiver should in a state to select only desirable FM frequency signal and rejecting all other frequency signals. To be more specific, your FM frequency band is also wider, that is it is varying from 88 megahertz to 108 megahertz band. In these bands also we will be having multiple FM channels. So our highly selective receiver should in a state to select only a specific channel such as your 91.1 or 93.5 megahertz or other frequency channels, and simultaneously it should in a state to reject all other channels so that we can tune into a particular channel and get the effective signal quality. So selectivity is obtained by using the tuned circuit. So obviously in order to generate certain carrier frequency, we'll be using certain tuning circuitry which are tuned to desired frequencies. For better selectivity, the quality factor should be high. So what is it and how it will going to affect our selectivity, we're going to discuss. So bandwidth of the tuned circuit is the measure of the selectivity. So here for tuning circuitry, we'll be using this tank circuitry, which is consisting of your capacitor as well as your inductor. The frequency generated by this particular tank circuitry will be equal to Fc is equal to 1 upon 2 pi under root Lc. This is well established relationship. You might all have studied that this tank circuitry will going to contain this C and L, and the frequency generated by this particular tank circuitry, or you could say the critical frequency, will be equal to 1 upon 2 pi under root Lc. So this particular figure is basically showing the gain bandwidth product curve of your typical tuned circuit or your band pass filter. So on the x-axis we'll be having this frequency, and on the y-axis we'll be having this your gain, or you could say your tuned circuit gain. So if you observe that this particular purple color curve is basically showing that it is highly selective, that is it will only going to select in these particular smaller frequency region only, or it is having some lower bandwidth. So obviously if we'll be demanding your highly selective filter, then that quality factor should be higher, whereas this particular yellow color curve is basically showing the high bandwidth, or conversely we could say that this particular filter will going to obtain or get larger amount of range of frequencies, or it will going to accept higher value of frequency signal. So conversely we could say that its selectivity is quite lower. So quality factor would have been given as your Q is equal to Fc upon bandwidth. So if bandwidth is larger, then quality factor will be lower. So if we really wanted that our filter circuitry or tuned circuitry should be highly selective, then it should operate on lower bandwidth ranges, and if bandwidth will going to get lower, then the quality factor will be higher. So designing this high quality factor filter will be costly. So hopefully now we have got the understanding that how high quality factor will going to result in your high selectivity. So now next particular term is your sensitivity. So obviously the typical receiver we are talking about, we should have to have a kind of receiver which is highly sensitive. That is, if receiver is lying a farther distance from your transmitter and it is obtaining some limited amount of signal power or very less amount of signal power, then also it should be in a state to get the actual signal back. So the ability of the receiver to detect the weakest possible signal is known as sensitivity. So obviously we will be requiring highly sensitive receiver. It is expressed in microvolts or in decibel. So this is the typical unit. The sensitivity of receiver mostly depends upon the gain of the intermediate frequency amplifier. So here this particular term intermediate frequency amplifier must be understood well. So point is, if we typically taking the example of your FM systems only. So FM system will going to lie between your 88 megahertz to 108 megahertz band. If you are talking about a single amplifier which will going to produce uniform gain throughout this FM frequency range, that is from 88 megahertz to 108 megahertz, it is quite impossible. That is, if you are talking about your high amplifier gain, and if you are talking about high bandwidth over which it is producing similar type of gain, so it is not possible. Basically, amplifier will going to possess non-linearity, or it will going to give some distorted outcome due to non-linearity. So what we actually do is we have to convert our signal or frequency, translate a signal to a specific range of frequencies over which our amplifier will going to possess uniform gain. Otherwise, we have to design different receivers for different sorts of channels. So here the idea is, for the entire range of operation of your FM frequency band, we have to convert our signal to a specific intermediate frequency. Then we have to process in that particular domain and finally demodulate to extract our message signal back. So this will going to serves our purpose and avoid the specific receiver designing for different channels. So the best way to improve the sensitivity is to reduce the noise level. So obviously, if we are in a state to reduce out the noise level, then the receiver sensitivity will going to increase, or we could say that at lower amount of signal also we can obtain our message signal back. So now next point is your fidelity. So obviously, at the receiving side, we will be requiring that the signal that has been generated at the transmitting side, the same signal we should get received at the receiver. So the ability of the receiver to reproduce faithfully all the frequency component in the baseband signal is called fidelity. So the same signal we will be requiring at the receiving side. If anyhow we will not going to obtain them, or we will going to get some distorted signal, so that is some sort of loss of information, and which is not desirable. So the desirable quality of your receiver is it has to obtain the same message signal back exactly as it would have been generated from the information source. So any variation in the demodulated signal that are not in the original information signal is considered as your distortion, which is highly undesirable. So if we talk about your fidelity, so we will be requiring some high fidelity receiver which are in a state to extract the same message signal as the original information one. So fidelity is difficult to obtain in your AM receiver because good fidelity requires more bandwidth, and bandwidth will be lower when we are talking about your AM signals. Only 10 kilohertz bandwidth will be there. So now the classification of radio receivers. So depending upon the application and the principle of operations of the radio receivers, they have been classified as, first one is your AM receivers. They are used to receive the broadcast of speech or music from the AM transmitters, which operate on long wave, medium wave, or short wave bands. All of us have seen your AM receiver application, such as Vivid Bharati or several different other transmissions would have been performed on these particular bands only. So second one is your FM receivers. This is a well-known application. We all must have aware of it. FM receivers receives the broadcast program from FM transmitters, which operates in your very high frequency or ultra high frequency bands, typically 88 megahertz to 108 megahertz. Then next one is your communication receivers. So they would have been used for reception of telegraph and shortwave telephone signals. Then your television receivers. So they are basically used for reception of your television broadcast. So they are being used to receive the television broadcast in very high frequency and ultra high frequency bands, typically in the order of hundreds of megahertz. Then your radar receivers, they have been used to receive the radio detection and the ranging signals. So typically radar would have been used for your ranging or detecting the objects. So now this particular slide is basically showing the typical intermediate frequency used for different sorts of applications. So for AM broadcast radios, we'll be using 262.5 kilohertz frequency as well as your 455 kilohertz frequency. So hopefully you guys have got the idea about why it is necessary to use this intermediate frequencies. Just because we are not in a state to design a particular amplifier which will going to produce the same amplification factor or gain over the entire range of frequencies. So it basically eliminates the desiredness of that particular thing. So next is your FM broadcast radio. It would have been using your again two intermediate frequencies, that is your 10.7 megahertz and 21.4 megahertz. Then your radar receivers, it is using your 30 megahertz. Your TV sets, they are using your 43.75 megahertz. radar receivers would have been again using your 60 megahertz, and satellite receivers typically using your 70 megahertz. So these are basically showing your typical frequencies, or you could say intermediate frequencies, that would have been used for different sorts of applications. So hopefully you guys have got the idea about the desirable properties of your radio receivers and the typical intermediate frequency used in different applications. Apart from that, the utility or usage of converting our message signal while receiving to a specific intermediate frequencies. So in case of any doubt, you can ask me in the comment section. I'll try to help you out as soon as possible. So these are the references. Thank you very much for your patient hearing.